So let's just start with limits. So first we'll take a function. Function of x is equal to y. So at point x is equal to a, we get function of a is equal to, let's say, L. So I'll take the number line. This is 0 and this is a. And let's take a set of continuously decreasing positive numbers h1, h2, h3, so on up to hn, such that h1 is greater than h2 and h2 is greater than h3, and so on up to hn, and hn is greater than 0. And then we'll mark them on the number line uh, like this, and this is point a plus h1, a plus h2, a plus h3, so on up to this point a plus hn. So the value of a plus hn can be made numerically small depending on the value of hn, and the greater the value of n, the smaller the value of h of n we get. That means greater the value of n, smaller is h of hn. So you can see we get functions, the function of these points as function of a plus h1, function of a plus h2, function of a plus h3, so on up to function of a plus hn. And if you see, we can write it as function of a plus h1 is greater than function of a plus h2, so on up to function of a plus hn greater than function of a, which is equal to L. That means the smaller h is getting, the closer we are getting to function of a, which is L. That means we can also write it as function of a plus n is nearly equal to function of a if hn is nearly equal to 0. Because as I said, the larger the value of n, the smaller hn gets, and a plus hn gets closer to a. That means we can write it as limit hn tends to 0, function of a plus hn is equal to function of a, which is L. So I can write it as, let's say, x prime. So I can rewrite the equation as limit x prime tends to a, function of x prime is equal to L. So this is what a limit is. So I can also say similarly from these equations, I can also rewrite it as a minus h1 and function of a minus h2, function of a minus h3, so on up to function of a minus hn. And basically this will be on the other side of a, and this will approach to function of a which is equal to L if hn is nearly equal to 0. That means I can rewrite it as limit hn tends to 0, function of a minus hn is equal to L. So using the same concept, I can rewrite it as limit x prime tends to a, function of x prime is equal to L. So this is what a limit is. And we can also say that sometimes this approaches to another number b, or we can, like here we have L. This can this series can approach to another number, let's say m. So generally in most of the cases we get L is equal to m. That means we can say that left hand limit and right hand limit are equal. And when left hand limit is equal to right hand limit, we can say that the limit exists. And the general notation would be in terms of x prime. We can write left hand limit as x prime tends to a negative function of x prime is equal to limit x prime tends to a positive function of x prime. So basically, positive represents the right side of the number line. That means this would be the right hand limit, and negative refers to left hand of the number line. So this is the left hand limit. So we'll be taking another example to understand fully what a limit actually is. So let's say I have function of x is equal to, let's say, x minus 4 upon x minus 4. So you can also say that this is equivalent to 1, but not exactly, unless we say equal to 1 provided x is not equal to 4. Why? Because let's say function of x at x is equal to 4, we get 4 minus 4 upon 4 minus 4, and then we get 0 by 0 form, which is indeterminate form, which is undefined. So how do we actually deal with these equations? So what I can do is I can say limit x tends to 4, function of x is equal to 1. That means the closer we get to, we can actually get infinitively close to 4, but we can actually never reach 4. That means we can take 3.99999 and we can also take 4.00001, but we cannot actually plug in the value of x as 4. So that's what a limit is. So a limit is like a boundary value to which we can get infinitively close but not actually that particular number. So this is what a limit is. So I'll be giving some questions based on limits. So these are some questions of limits which I have actually written on the board for you to solve. But before coming to these questions, I would give more example of how we use the limits. So basically, we use limits to calculate in indeterminate forms, and two of them are infinity by infinity, and one is 0 by 0. So we have no mathematical tools to actually deal with these types of equations. So what we do is we use limits to solve these questions. So let's just say I have a question, limit x tends to a, x square minus a square upon x minus a. And I want to find the limit of this particular equation. So I cannot just plug in the value of a unless, and if I do, I get a minus a in the denominator, and I get 0 by 0 form, because it will also become a square minus a square, so we get 0 by 0 form. So not just 0 by 0 form, in fact, any number by 0 form is an indeterminate. So what I'll do in this case is, I'll write limit x tends to a, x minus a into x plus a upon x minus a. Why? Because a square minus b square is equal to a plus b into a minus b. So this will cancel out, and then I'll put the value of x is equal to a, and I get a plus a is equal to 2a. So another example which we can take is mm, 2x upon 1 plus x. And I want to find out the limit of this equation. Because if I go on increasing the value of x, so see, so the closer x gets to infinity, we get infinity by infinity form, which is indeterminate. So how do I deal with such equations? So I can do is I can divide the numerator and the denominator by x, and then I'll get 2x by x upon 1 by x plus x by x, which is equal to 2 by 1 by x plus 1. And now I can actually put x is equal to 0. So I get 1 by infinity plus 1. So any number by infinity we get 0, because when the denominator is infinity, so no matter what the numerator is, the whole fraction would tend towards 0. So I'll get 2 by 0 plus 1 is equal to 2 by 1 is equal to 2. So I can write it as limit x tends to infinity, 2x upon 1 plus x is equal to 2. That means the closer x is to infinity, the closer we get to 2. But actually x will never get to infinity and we'll never get the fraction as 2. So it's just a fancy way to write the closer we get to infinity, the closer we get to 2. So now we'll be solving these questions. So first we'll do this one. Limit x tends to 5, x square minus 25 upon x minus 5. So if I put x is equal to 5, I get a 0 in the denominator, which means I get an indeterminate. So what I can do is I can do limit x tends to 5, x minus 5 into x plus 5 upon x minus 5. This cancels out. Put x is equal to 5. I get 5 plus 5 is equal to 10. And then the second question, I have limit x tends to 6, x square minus 5x plus 12. So what do we have in the denominator? We don't have anything, or we just have 1 in the denominator. So this can never get into any sort of indeterminate form. So I can just simply plug in the value of 6. So put x is equal to 6. I get 6 square plus 5 into 6, sorry, minus, plus 12. I get 36 minus 30. 12 is equal to 18. The third question is limit x tends to 4, x cube minus 64 upon x minus 4. So again, if I put the value of x, I get an indeterminate. So how do I break this down? So what I can do is I can use the identity a minus b into a square plus ab plus b square is equal to a cube minus b cube. So I can write it as x tends to 4, x minus 4 into x square plus ab 4 into x plus b square, which is which is 4 square 16 upon x minus 4. This cancels out. put x is equal to 4. I get 4 square plus 4 into 4, again 4 square plus 16, which is 4 square. I get 16 into 3, 48. So the third question is, limit x tends to 3, 1 by root x minus 1 by 3 upon x minus 9. It's 9 actually, sorry. So I can simplify the numerator. X tends to 9. 3 minus root 3 upon 3 root, sorry, it's root x minus 3 root x into x minus 9. 3 root x into root x minus 3 into root x plus 3. It's equal to limit x tends to 9. I can take one common. 3 root x into root x minus 3 root x plus 3. This cancels out. I get minus 1 upon 3 root x into root x plus 3. So I can put in the value of x is equal to 9. I get 3 root 9 into root 9 plus 3. Root 9 is 3, so I get 3 into 3, 9 into root 9 is 3 again, so 3 plus 3 is 6 is equal to minus 1 by 56. Sorry, 54. The fifth question is, limit x tends to 49 root x minus 7 upon x minus 49. So this is again same as the first question. So limit x tends to 49 root x minus 7 upon root x minus 7 into root x plus 7. This cancelled out. I get 1 by root x plus 7. So put x is equal to 49 and under root 49 is 7, so I get 1 by 14. So now comes last two questions, which are x tends to 0, root 3 plus x minus root 3 minus x upon x, and second question is limit x tends to infinity, x square plus 3x minus 2 upon 2x square plus 3. So what I can do is, in question number 1, I can simplify it as let a is equal to under root 3 plus x and b is equal to under root 3 minus x. So I get limit x tends to 0, a minus b upon x, and I will rationalize this by multiplying by a plus b upon a plus b. So from the identity, I will get a square minus b square. So limit x tends to 0, a square minus b square upon x into a plus b. So I will plug in the value of a, and a square will be 3 plus x and b square would be 3 minus x. So I'll do limit x tends to 0, 3 plus x minus 3 minus x upon x into root 3 plus x plus root 3 minus x. So minus minus plus and minus plus minus, 3 cancels out, we get 2x. Limit x tends to 0, 2x upon x into root 3 plus x plus root 3 minus x. So x cancels out. I get limit x tends to 0, 2 upon root 3 plus x plus root 3 minus x. So even after plugging the value of x is equal to 0 here, I will not get any indeterminate form. So I will just put in x is equal to 0. Put x is equal to 0. So 3 plus 0 is 3 and 3 minus 0 is 3. So I will get 2 by root 3 plus root 3, 2 root 3, 2 cancels. I get 1 by root 3. So the answer is 1 by root 3. So yeah. So I'll do the second question now. So here, so what I can do is, if I put the value of x is infinity, I get again infinity by infinity, which is an indeterminate form. So I'll simply write down the equation again. Limit x tends to infinity, x square plus 3x minus 2 upon 2x square plus 3. So we'll do dividing, we will divide the numerator and denominator by x square. So we get limit x tends to infinity, x square by x square plus 3x by x square minus 2 by x square upon 2x square by x square plus 3 by x square. This cancels, it becomes 1, cancels, and yeah. So I'll get limit x tends to infinity, 1 plus 3 by x minus 2 by x square, 2 plus 3 by x square. So I think you now know what to do. Just simplify, just simply put x is equal to infinity. So when x is equal to infinity, three by x is equal to 2 by x square is equal to 3 by x square is equal to 0. So I get 1 plus 0 minus 0 upon 2 plus 0, which is 1 by 2. So this is equal to 1 by 2. So basically, in this, what we had to do, we had to eliminate x square from at least one term, so we get a whole number or a real number, because we did not want to put infinity over here. So when we get a whole number or a natural number, you could say, or even an integer, it just depends upon the quotient which we are doing. We wanted to eliminate x square from each term, because if I had put the value as of x as infinity, I would have gotten infinity by infinity form, which is equivalent to which is actually indeterminate. So what I did was, I knew that any number by infinity is equivalent to 0. So this turned into 1 by dividing by x square, and this turned into 2. And the rest, after putting the value of x is equal to infinity, I got 0. So here we have the value of this equal to 1 by 2. So I hope you understand the video and now you know what limits are. Thanks for watching.